Alright, let us solve this structure ACDE, where two members AC and DE are connected by a two force member CD. Here CD is a two force member. CD is a two force member because it has hinges on both sides and there is no any external load applied, and we know that two force member can only transfer forces in the direction of the member itself. So let us break this structure at point C and D and draw our free body diagram. Let's look at member AC. At point A, we have a pin support, so we will have a vertical reaction and then a horizontal reaction. At point B, we can consider the support as roller, so vertical reaction at B. And then at C, let's consider this CD is in compression, so force in CD is FCD. Distance between A and B is 6 feet, and then B and C is 3 feet. Similarly, member DE, this force CD is equal and opposite, transfer through AC to CD through CD. So this is point D, and at E we have pin connection, so vertical reaction and then horizontal reaction. Now let's look at external load applied. We have uniformly varying load at member AC, which has a magnitude of 8 kPa per foot. So equivalent point load would be the area of the triangle, half into 9 feet into the height 8 kPa per foot, which would be equal to 36 kPa, and the distance would be 1/3 from this side, so 1/3 of 9 feet would be 3 feet from C. So our equivalent point load of 36 kPa lies at point B. Similarly, there's another external load in member DE, which is 5 kPa. Its equivalent point loads, vertical and horizontal, would be 4/5 of 5 kPa and then 3/5 of 5 kPa because of the slope 3, 4, 5. The distance from C, this is 6 feet and then this is 2 feet. Let's look at the determinacy of this structure. We can count the total number of unknown reactions in this structure. Here is 1, 2, 3, 4. This is the same point C and D, so counts as 1. So 1, 2, 3, 4, 5, and 6. We have 6 number of unknown forces. We have two elements, AC and then DE, connected by two force members CD. So 2. Then we will have 2 times each member will have 3 equilibrium equations, so 6 number of equilibrium equations. Then determinacy would be equal to 0. That means that structure is statically determinate. So we can solve this structure by applying equations of equilibrium. We can either start from member AC or member DE. Let's look at member AC. If we take the moment about A equal to 0, then AX and AY would be cancelled out, but we would still have two unknown forces, BY and FCD. However, if we start from member DE, if we take a moment at E to be 0, sum of moment at E to 0, EY, EX would be cancelled out, and we can actually calculate the FCD value. This force can be transferred to this member AC, and then we can easily solve other reactions out here. So let's start from section DE. Here, let's take moment about point E to be 0. Then consider counterclockwise moments positive. The compressive force from FCD will exert counterclockwise moment about point E. So be positive FCD times the moment arm is 8 feet. Similarly, the vertical component of this 5 kPa load would exert counterclockwise moment as well. So 4 by 5 of 5 kPa times the moment arm 2 feet, and do we have any other forces? No. So this summation of all these forces should be equal to 0. This will give us the value of CD to be -1 kips. The negative indicates that the assumption of member FC being in compression is not true. This is actually the FCD would be 1 kip acting upward, so this would be upward and this would be negative. So member FCD is actually in tension. Moving forward, if we take summation of all the vertical forces in member DE to be 0, considering upward force is positive, then we can start from point D. We have upward FCD. We just corrected it based on the value we got. We have the vertical component of 5 kips acting downward, and we have the vertical reaction at E equal to 0. We just calculated FCD to be 1 kips. Therefore, the vertical reaction at E would be equal to 3 kips. And another equation of equilibrium, summation of all the forces in x direction to be 0, considering forces towards right to be positive, then we have a horizontal component of this 5 kips acting towards left, so -3/5 of 5 kip, and we considered the horizontal reaction at E to be towards left as well, so -EX. Summation of all these forces to be 0. This would give us the horizontal reaction at E to be -3 kips. Again, this negative means that our assumption of EX to be towards left wrong, so this would actually be 3 kips acting towards right, like this. Now we can move on to member AC with the value of FCD that is 1 kips acting downwards because it's in tension. Section AC, if we apply summation of moment at point A to be equal to 0, considering counterclockwise moment positive, then the equivalent point load from the uniformly varying load of 8 kips per feet is causing clockwise moment about point A. So this would be -36 kips with the distance 6 feet from point A. The vertical reaction at B is causing counterclockwise moment, so By times moment arm 6 feet, and then the tensile force in member CD is causing clockwise moment again, so -FCD times the moment arm is 9 feet. The summation of all these forces would be equal to 0. We calculated FCD to be 1 kip. Calculating this, we get By to be equal to 37.5 kips, and this would be acting upward because we got the positive value. Another equilibrium of equations in member AC. Let's apply summation of forces in y direction to be 0, considering upward positive. Then we have from point A, AY, plus at B, BY, minus the applied load 36 kips, and minus FCD, which is acting downward. Sum of all these forces would be 0. We now know By is 37.5 kips, FCD is 1 kip. Therefore, solving this, we get reaction at A to be 0.5 kips, and our assumption that it's vertically upward is true. Finally, summation of all the forces in x direction to be 0, towards right would be positive, then AX, and looking at this free body diagram, we don't have any external load applied horizontally, so AX would be actually 0. So summarizing all these forces, we have vertical reaction at A 0.5 kips. We don't have any horizontal reaction at A. At E, we calculated vertical reactions to be 3 kips, and then towards right, which is 3 kips, and then at B, the vertical reaction was found out to be 37.5 kips.